In this video, we are going to see about one of the important topic in thermodynamics, Otto cycle, diesel cycle and dual cycle. These are all the basic three cycles which is applicable and applied in most of the all the engines in real-time applications, all the IC engines. For example, if you take an automobile, what we are using in day-to-day life, example a car, a bike or anything, it may be a military vehicle or a marine ship engine, everything is comes under Otto cycle, diesel cycle as well as the dual cycle. So this is one of the important topic in thermodynamics. In this session, we are mainly focused on these topics. First, we will go on to Otto cycle. Otto cycle is applicable in petrol engines, and petrol engines are it is said to be an spark ignition engine. In that engine, we are using a spark plug. In that engine, there are four major processes as I given in the graph. The first process is isentropic compression or adiabatic compression. Adiabatic process is also comes under isentropic process. So we don't need to worry about it. Both are same. And the first process 1 to 2, as I marked in the figure with the arrow mark, you can see 1 to 2 is isentropic compression. There will be a compression of piston inside the cylinder. This is the first process. After that process, we need to add the heat in constant volume. This is the second process. At constant volume, heat is getting added in the engine. Due to the compression, after the fuel is getting injected, with the help of the spark plug, the fuel is getting ignited. The power stroke will come into picture. So due to the power stroke, the heat will be added. So this is a second process. From 1 to 2 is a isentropic compression. 2 to 3 is a constant volume heat addition process. And then 3 to 4 is an isentropic expansion process. In the expansion, the piston which is moved to the top will be coming back to the bottom in the internal combustion engines. So this is a process from 3 to 4, and again 4 to 1 there will be constant volume heat rejection will come into picture. So in the constant volume, the exhaust through the exhaust valve, the exhaust gas, the waste gas will be sent out. It contains a NOx, carbon monoxide and hydrocarbons. So these kind of emissions will be go out in the exhaust valves. These are the four major processes in Otto cycle. As I given in the figure, PV diagram and the TS diagram. PV diagram is a pressure versus volume. TS diagram is a temperature versus specific entropy. This is the two basic diagrams. In interview, they may ask to draw this kind of diagram, so we should be very ready about it. This is the basic process in in Otto cycle. In PV diagram as well as the TS diagram, the process is same. 1 to 2, 2 to 3, 3 to 4 and 4 to 1. The similar process is applied in both the figures. So there is no change in process in change in diagram. So what the process is applied in PV diagram, the same process applied only TS diagram. So there is no change. This is the process in Otto cycle. Otto cycle is used for petrol engines, what we are using in day-to-day life. For example, Honda, like most of the vehicles, what we are using in day-to-day two-wheelers, we are taking a fuel as petrol. So these kind of vehicles works with the help of the Otto cycle. And then next we will move on to diesel cycle. Diesel cycle is also called a compression ignition. In the compression ignition, the fuel is getting power with the help of the compression of the piston without having any kind of spark plug. So in this graph, there are four major processes. There is a slight difference between petrol engine as well as a diesel engine. The difference we are going to see over here. The isentropic compression, the same procedure is also coming over here from the 1 to 2 process. As I given in the figure, you can able to see from 1 to 2 isentropic compression or adiabatic compression. Adiabatic compression is also comes under isentropic compression. Don't confuse about it. So after that, there will be constant pressure heat addition. In Otto cycle, there is constant volume heat addition, whereas here constant pressure heat addition. Because in Otto cycle, the piston comes to the TDC. TDC means top dead center. After reaching to the top dead center, the fuel is getting injected. After that, spark is applied. Due to the spark, there will be power stroke will be happen. After the piston is come to the top dead center, there will be a constant volume. So in that constant volume, we are giving an external heat. So that process is constant volume heat addition in Otto cycle. Whereas in diesel cycle, the fuel is getting injected even though the piston going down. If the piston going down, there will be a constant pressure. You may think when the piston going down, the volume increases so that the pressure may decreases, right? Then how you are saying pressure is it is a constant pressure? Because after the combustion process there will be a power stroke. Due to the power stroke, the temperature will rise. So due to the temperature rise, the temperature compensates the pressure to be constant. So by this way, the heat is added at constant pressure in diesel cycle. After adding the heat at constant pressure, there will be an isentropic expansion, the same process, and then constant volume heat rejection will be there. At the exhaust gas or exhaust valves, the same process will coming into picture. There will be constant volume heat rejection will be there. So this is the four major process which is applied in PV diagram and TS diagram in diesel engines. So this cycle is applicable in diesel types of engines what we are using in industrial manufacturing. What are the cars or any kind of vehicles. In bikes also they will use diesel. In Royal Enfield advanced models, some bikes they will use diesels. So this is applicable to diesel engines. Next we will move on to dual cycle. Dual cycle is also known as real-time diesel heavy machinery vehicles, which in that vehicles they will use this kind of cycles because it gives a better output, and it is a real-time cycle when compared to the other two cycles. It is a real-time cycles in diesel vehicles. In this cycle there is first process 1 to 2 is isentropic compression, the same process which is applied in Otto cycle and diesel cycle. Here also it is applied in dual cycle, isentropic compression, and then constant volume heat addition from 2 to 3. Here the heat is added at constant volume as well as the constant pressure. From 2 to 3 constant volume heat addition will be there, and from 3 to 4 constant pressure heat addition is there. The both heat addition will come into picture in dual cycle. So this is a practical heavy diesel vehicles. This is a practical thing. The dual cycle is applied in practical diesel heavy vehicles. This is a very important thing. And then there will be isentropic expansion, and then there will be a constant volume heat rejection will be there in the dual cycle. The same process is applied in TS diagram also. In the TS diagram, temperature is a specific entropy. Entropy, already is a measure of randomness, and specific entropy means it says that with respect to unit mass, per unit mass. The unit of specific entropy, I already mentioned, joule per kg Kelvin. If you are talking about a normal entropy without having considering about a unit mass, then we can say it as joule per Kelvin. So this is the basic difference. We are here providing for temperature versus specific entropy, not temperature versus normal entropy without considering the mass. And this is the process for dual cycle. In general, dual cycle is applied in many of the vehicles, as I in Maruti, Hawk, this kind of models, and military vehicles, and also in marine internal combustion engines. A dual cycle plays a crucial role. So from this video we have learned about Otto cycle, diesel cycle, and a dual cycle as well. I hope this video is useful for you. Thank you.